Welcome to this demo powered by VMware and Juniper Networks Technologies. Juniper and VMware are long-standing mutual technology alliance partners. And over the past few years, Juniper has delivered a great number of product and feature integrations with VMware that places us as the network vendor and security services gateway vendor of choice for customers using VMware technologies, whether it be from small solutions based on vSphere to large comprehensive software-defined data centers with vRealize Suite and NSX, or even hybrid clouds with vCloud Air. You could count about a dozen different product integrations to unify your VMware data center and virtualization operations with your Juniper network. That's a lot more than we can cover here, so we'll put some links to a few more demos in the YouTube description below this video. In this quick demo, we'll see one new way to unify your data center operations. We'll show the latest 6.2 version of VMware NSX for vSphere in action, managing virtual overlay networks that are bridged to bare metal servers through a Juniper QFX series high-performance Ethernet switch. Now let's get to the demo. Here you should already be familiar somewhat with how VMware NSX manages the virtual overlay networks to connect VMs with what it calls logical switches. When you need connectivity for bare metal servers, other network service appliances, or even VMs that aren't under the control and reach of NSX, what an NSX operator will need is a gateway router or switch that can bridge the VXLAN overlay networks with physical networks, be they VLANs or anything else. Juniper provides a range of devices that can do this, but here let's look at the popular QFX high-performance Ethernet switch and its VXLAN tunnel endpoint, or VTEP, features. In this demo, we'll show you the physical network operator's workflow first, on the switch CLI, though it could also actually be done in Network Director. After that, we'll jump to the workflow for the orchestration operator in the NSX web user interface, which is built into vSphere web client. The orchestration operator doesn't need to touch the physical switches or the Network Director management system at all. We'll show how you can get the network to extend the NSX logical switches automatically over the OVSDB protocol to the physical switches once the initial switch configuration is in place. What's more is that the QFX switch we're using will be bridging in and out of the overlay network at line rate, and it offers hitless in-software service upgrade. So the traffic just continues to flow with hitless high performance even if the network operator decides to upgrade the Junos operating system on the switch without telling the orchestration operator. Okay, getting started, let's go to our QFX switches CLI and show you that for this initial configuration, we've set up 4 10 gig interfaces or ports on which to connect bare metal servers, for example. We've connected an OVSDB connection to the master NSX controller node, and finally, you can see that it's not yet connected, and we've no logical switches from NSX on which to bridge the VXLAN traffic yet. To connect NSX to physical switches over OVSDB, we need to take the security certificate from the switches and input it into NSX. This can easily be done by just sharing the text form of the certificate with the NSX operator. Now, flipping over to NSX, I can input that certificate that we originally copied from the file on the switch. And as you can see, the switch connects almost immediately to the NSX controller. But as of yet, there are no NSX logical switches shared with this physical VXLAN tunnel endpoint. If we jump back to the CLI for the switch for a second, we indeed see that it also has connected to all 3 NSX controllers in the cluster, the master node, for which we input the IP address, as well as the other 2 nodes that it learned. The switch is also reporting that it still has no logical switches, just like NSX does. So let's jump back to NSX and add some. In the view of all of our logical switches here, we select LS1 and attach a hardware port. In the dialog box that comes up, we select the name of our switch that we are going to be calling Juniper, and then add one of the physical ports that was enabled on the switches for VXLAN bridging. So here we choose the interface XE0011 and VLAN number 4. As soon as that configuration takes hold, the physical switch can report the MAC addresses learned on its configured VLAN to NSX and learn all the MACs in the VXLAN overlay and begin bridging so that the VMs attached to the overlay can reach the bare metal servers and such on the VLAN and vice versa. If we go back to the CLI now, we'll see that the logical switch reports that it is indeed bridging VXLAN number 6001 for a total of 51 VM endpoints and 1 local bare metal endpoint. It will do this with the physical port and VLAN just as configured in NSX, which we can also see here now as well. Also, we can see that Junos OS has gone ahead and added all of the necessary VLAN and VXLAN configurations into its own configuration database, based on the automations that it received over OVSDB from NSX. Finally, we can test and see connectivity and reachability too. If we do a show OVSDB MAC remote multicast command, we see the endpoint hypervisor host addresses that will receive BUM traffic in the overlay and have joined the multicast group for this logical switch. If we do a show OVSDB MAC remote unicast, we see all of the 51 remote VM MAC addresses and their respective hypervisor host IP addresses. If we do a show OVSDB MAC local, we get only the switch interface itself in the multicast group, and the unicast IP addresses have actually not yet populated. But if we jump onto our bare metal server for a second and ping one of the VMs in the overlay, then we'll see this change. So let's indeed start a ping test, and thus also an ARP from our server, and then come back and reissue the same Junos command. And now we see that indeed the MAC address for that bare metal server is showing up in the logical switch with its VXLAN tunnel endpoint as our physical switch interface. As you can see, it's all very simple for the orchestration operator, and at the same time, it keeps the network operator fully in the loop of everything that's going on as well. So that's it for our demo. To find out more about orchestrating and automating your Juniper network and unifying your VMware data center operations, check out more demos like this one and our joint solution brief, linked in the YouTube description below. Thanks for watching.